Welcome. One of the features in Snowflake that customers rave about is our cloning capability. Today, as part of our new series, Snowflake Insider, our customer success engineer, Faisal Sharani, will take you through a guided tour. You'll see how cloning in Snowflake works, how to get started cloning today, and understand real-world scenarios where cloning should be used to deliver value. We have just one bit of housekeeping. You are in listen-only mode. You may enter questions at any time in the chat and question box below. We will have a Q&A session at the end. The recording and slides will be made available to you from the Snowflake support portal. And with that, it's my pleasure to introduce Faisal.
Thank you, Jane. So before we start talking about cloning in Snowflake, it is very important for us to understand how data is stored within Snowflake. When data is loaded into Snowflake, data is loaded in small compressed files called FDN. And these FDN files are maxed up intentionally or by design at 16 megabyte in size. So if you have a whole terabyte of data of a CSV or any other type of data that you're loading into Snowflake, it will be stored in small 16 megabyte files with a .fdn extension. And it's structured as an MPP columnar format with metadata zone map information about each of these data files that facilitates pruning, and it's going to speed up the data I/O, read and write into the database when you're executing your SQL statements. So now that we've covered how data is stored in Snowflake, we can start talking about cloning, and it's also known as a zero-copy clone, where there's really no duplication of storage. In the traditional world of databases, when you wanted to replicate a table, it will just create a duplicate copy of it, and therefore you're doubling your storage of that particular object. And if you're copying a database, you're going to be doubling your storage of that database as well. With cloning, that problem of duplicating storage, which could be slow depending on the size of the object that you're duplicating, or the effort that is going to be involved as far as using DBAs, using the IT organization, the cost of storage, the cost of infrastructure, that could be totally a burden for this effort. While with cloning in Snowflake, all of that is made very, very simple. The process of cloning a table or cloning a database does not incur any additional storage. It's basically taking a snapshot of the data as of that moment in time when you're performing the cloning operation. And any subsequent changes, incremental changes to the original object or to the cloned object, are kept track of separately in separate additional FDNs. And so the characteristics of the cloned object, whether it be a table or a database or a schema, is such that they are writable, so they're read-write. They fully function like the original object, be it a table or a database that you've cloned from. They're totally independent from the cloned object. As I said, any changes to either the cloned object or the original object were kept track of separately since the snapshot is taken. And then any higher level cloning, so if you clone a database, all the objects underneath it, tables and schemas, will be cloned as well at the same time. This diagram here depicts the, in a simple picture here, what I just described earlier about how objects are stored or how data is stored within Snowflake, and how the cloning process flows. You see here the Snowflake hierarchy in terms of a database, then you have the schema, and then you have the tables within that schema. And our picture here shows how an original table at the top of this diagram here, this different shades of blue, is a table, an original table that is made up of the series of these FDN files that are stored in S3, as I mentioned earlier. And when you take that, when you clone the table below that we see on the screen here, it basically freezes those set of files, takes a snapshot of those files, and make that snapshot available to the cloned table. And any changes at that point on the cloned object or the original object are kept track of separately. And so there's that shared data here, the single one file, set of files of the original object when it was cloned, and then the additional sets for the incremental changes. Now that we learned about cloning in Snowflake, you may wonder, how's that beneficial for me in my day-to-day activities, and how can I apply that to really my business scenarios or use case scenarios. So the first use case scenario that we're presenting two use case scenarios in this webinar. The first one is taking a snapshot as of a moment in time. In the traditional old database world, if you wanted to take a snapshot of a table for audits possibly that are happening at the end of a month or the end of a quarter or the end of the year, you would have to create copies of these tables or copies of this database. And it would be a little bit of an effort because you would have to involve the IT organization, your sysadmins, your DBAs. You have to have a process established. You have to incur additional infrastructure costs in terms of storage or servers, etc. So with cloning, all of that stuff goes away, and you, with a single command, as user of Snowflake, are able to issue a command to clone a table or a schema or a database. That would freeze it in time. That will give you basically a simple backup, if you will, as well, of your database or your tables, and it gets set up in no time. So to just give you an idea, we were able to clone a 1 terabyte database on a small warehouse. A small warehouse is using 2 compute nodes or 2 virtual machine servers. 1 terabyte took about 7 minutes to clone, and obviously the bigger the data set, the more time it takes. But also you can resize your warehouse and then use it on, run it on a medium or a large, if you wanted the operation to happen faster because you have a larger data set. And of course, we mentioned the cost saving, on resources that don't need to get involved with this process anymore, and then cost savings on additional storage and additional infrastructure that you would not need with the Snowflake cloning feature. So now that we talked about this use case scenario, let's take a look at how that works in action, in real life. So I'm going to be sharing with you here my Snowflake UI, where I have some existing example that I've coded over here, and you'll see it on in the slide deck when we share it. So we'll start, we'll run through the scenario first and then execute it step by step to show you the, how we cloned a table of an original table. So we're going to create a table. We're going to load it with data here with a couple of sample rows. Then we're going to check on the content of that table, see what it looks like, then create a clone. Then we're going to insert and update records in the original table. And then we'll take a look at the status of the cloned table, what content it has, and how different it would be, or similar, depending on what we've done, to the original table. So let's take a look at these steps in action. So we're going to execute the first statement, which creates our table. And we're going to execute the insert statement, which inserts 4 records for us. Well, it's telling us here that there's no warehouse that is active, so we're going to make sure we point to our warehouse. We're going to make sure we point to our database, which is DemoDB, and now we're going to try this operation again, where we're going to select from the table employees. Well, we haven't run our insert statement, so we're going to run our insert statement, inserted 4 records, and then we'll take a look at the content of the table. We'll have 4 records in that table. Then we're going to create the clone of that table. So now we have our employees clone table that's been created. If we take a look at that clone table right now, which is called employees clone, we're going to see the 4 records existing, very much exactly the same copy as the employees table that we cloned this from. Now we're going to go make a change to our employees table. So we're going to insert an additional record, and then we're going to update one of the existing records. So we're going to insert this record of employee 500, and we're going to change the existing employee record, change the last name from Fox to Wolf. And so we're going to do this update statement over here. And now let's take a look at our clone table. Our clone table should remain the same, and you'll see the 4 original records and the last name of employee 400 being Fox. If I go and look at the content of the employees table, I'm going to see 5 employees, and I'm going to see employee 400 last name change from Fox to Wolf. And as is the case over here, we'll see employee 500 getting added to the employees table, and then we see the change that happens in the original table because we executed 2 DML statements on that table, and the changes are independent from the cloned objects, the employee clone table. This concept of cloning, again, I want to reemphasize that it can be extended from the table to the schema to the database. All these 3 different things can be cloned in Snowflake. Now we'll go back to our slide deck here to take a look at the second use case scenario. So the first use case scenario, as I mentioned, is coded in the slide deck, so you'll have access to that code, to that example, to take a look at it. And now we move on to the second use case scenario. And the second use case scenario is also something very common in the database world. You might have run into that, is creating 3 separate environments for release management, or 3 release management environments where you have to create a development environment, you have to create a staging environment, and a production environment. And oftentimes you have to sync your production environments with your staging environment to do QA before you release to production. In the old world, you would have to set up an infrastructure, set up copies of the production database in the staging environment, create a copy of production, duplicating the data, and if you have to do the same thing on development, you have to have now 3 copies of the same data set that's originally in production. That takes time. That is costly. You incur additional storage cost. You incur resource costs to maintain and manage that environment, and it takes time. Simply, when you wanted to replicate a production environment into a stage, and you're talking about a massively large database, this is not going to happen in a matter of minutes. I mean, it could take you hours. It could take time to be scheduled, all that stuff. And so it is. In the old world, it's not cost effective. It's not fast, and it requires a lot of involvement from the IT organization. Now, the Snowflake cloning copy of a database would allow you to really perform this setup of a release management environment and clone your production environment fairly fast and really without incurring additional cost of storage to these other environments. And so if we go back to our UI, the Snowflake UI, and do share that UI with you over here again, the second set of code that I have here is cloning a database. And now we're going to see this in action where I'm going to create a cloned database of my demo DB, and I'm going to then drop the tables that exist in that clone, and then I'm going to see if this dropping of the tables, see the difference between the cloned database and the original database. So let's take a look at that. First, we go back to our databases. I want to make sure that I share with you what is available. So we have our demo DB, and we have in our demo DB the 2 tables, the employee clone table that we cloned on our first example, and we have our employees table, the original table as well. So now going back to our worksheet, I start executing this first command, which creates a database clone for me. It's called demo DB clone. So what I do is I execute this command. And I have to select that command to execute it only and not the comments that are out there. So now we have our DemoDB clone created. If I go back to our databases, we'll see the DemoDB clone, which is now having the 2 tables, the employees and the employees clone table. It's very exactly the same copy as of the DemoDB. Now I go back to worksheet, and I'm going to decide to drop from my clone the tables, the employees table. So here you see I'm dropping from the DemoDB clone my employees table that we just saw. And I'm going to also drop my cloned employees table as well from that DemoDB clone, as we're pointing here on that dot notation path over here. Then when we do show tables, as I'm pointing to my DemoDB clone right now, when I do show tables, I see nothing because there are no tables anymore. I dropped them. And if I go back here to my databases, I'll see that the DemoDB clone does not have any tables. On the other hand, if I go back to databases and I click on DemoDB, I'll see that my original tables of employees clone and employees still exist. And so that pretty much it is for the second use case scenario. So I'm going to go back to our slide deck over here. And again, as I said, the code is already in the slide deck, and so you'll have access to it as well. So that wraps up the portion of our talk and our demo as well. And we're going to go to the Q&A session at this point in time. Thank you.
Great. Thanks, Faisal. Our first question is about snapshots. Is it an image file, or is it stored differently than FDN files?
Essentially, the snapshot it's really not creating any additional FDN files. So a snapshot is really the original set of FDN files as of that moment in time when you took the snapshot. And as you saw in the architecture diagram, the additional changes, be it an insert or update or delete, that takes place in the cloned table are kept track of separately in incremental set of FDN files, and vice versa. The same thing applies to the original object. Any changes that happen past that snapshot will be kept track of in additional FDN files. So yes, the snapshot is a set of FDN files, but they're the original FDN files that are now shared by the two objects, the original and the cloned one.
Can we create views on top of cloned databases?
Yes, you can create views on top of cloned objects and databases, or the databases, views within the cloned databases themselves. Cloned tables are exactly the same as original tables. Whatever you can do on an original table or just a plain table in a database, you can do on the cloned object as well. Cloned tables are writable, readable, and they're comprised of the same exact structure of FDN files as an original table.
Great. Will customers incur additional storage costs from cloning?
No, there's really no additional cost if you clone an object from an original object. So if you have a table and you clone it, and you don't make any changes to either the original table or the cloned table, the cost of storage is just one and is the same for no matter how many cloned copies of that table you make, because they're all really pointing the same set of data files. But the additional cost or the incremental cost happens is when you start making changes to either the original table or the cloned set of tables, be it one or many, whereby there's new FDN files that are created, and of course they're going to house additional data, and therefore there's incremental cost. But the original set of FDN files is just a cost one time.
Great, thank you. Well, that's the end of our questions. I want to thank Faisal for his demonstration, and thanks to all of you for attending today. Slides and recording will be made available from the support portal. We look forward to seeing you at Faisal's next Customer Success Workshop. Thank you.